Suppose we have trained a model which is really good at classifying dog images. And now we query the model with this image to test it. And we find that the model classifies the image correctly as the image has a dog in it. Wouldn't it be interesting now to ask the question, what made the model decide so? Or rather, where is the model looking at? Grad-CAM is a technique which helps us answer this question by showing us where the model is paying attention. Before moving on to the generation of Grad-CAM, a quick note on what actually makes a good visual explanation. First, it should be class discriminative, that is, localize the category in the image. And second, high resolution, that is, capture the fine-grained details in an image. Grad-CAM can produce visualizations for any layer L. Usually this layer L is taken to be the last layer. Here, A1, A2 and AK are the activation maps produced after the layer L. We can think of the class activation score for a particular class C as a function of these activation maps. How Grad-CAM generates a visual explanation map is by seeing what features in these activation maps are important in the prediction for a particular class. For example, take a particular location I, j in an activation map. We can easily see how the changes in this location creates a change in the class activation yc. This can be formally written down using a partial derivative of yc with respect to that location. Summing over such derivatives for an activation map gives a sense of how important the activation map is for predicting the yc. The final form of Grad-CAM is not hard to understand from here. It is a summation of all the activation maps, weighted by their importance, which is captured through the partial derivatives. The ReLU is used to pick only those parts of the activation map which have a positive effect on the class activation yc.